Welcome to the NCV Mathematics Level 2 once again. Exponential equations is our topic, and we have to solve these exponential equations. There are a few rules we need to look out for. Rule number 1 is that if the bases are the same, then the exponents are equal. Bases would be the number at the bottom, exponents would be on top. So here 3 and 3 is the same. So because of this rule, now automatically we can say that x must be equal to that exponent, which is equal to 4. In the rule number 2, we say that if the exponents are the same, then the bases are automatically equal. So in this example, x to the power 4, 3 to the power 4 is 4 and 4 are exactly the same. So automatically, therefore, x will be equal to that base, which is 3. A few things to remember: when we have integers or numbers, we can reduce them to exponents to be able to use rule 1 and rule 2. Like if we have a 9, we can change it to 3 to the power 2 to make the base a 3. 16 can be written as 4 to the power 3, 64 can be written as 2 to the power 6, and so on. 125 can be written as 5 to the power 3. And so we need to know how to change a number, integer, to a exponent form. This is very important, that we need to know how to do this. In my first example, I've got 2x to the power x equal 4. 4 is not the same as 2. The bases are not same. No rule can be applied. But if we manipulate that 4 and change it into a 2 to the power 2, using the integer, changing it to an exponent, we can now see the bases are the same. 2 and 2 are the same. So therefore, rule 1 can apply, and x will be equal to the exponent 2 there. In my next example, we've got 125, and we need to change that 125 to make rule 1 or rule 2. If we change 125, we can change it to 5 to the power 3. So bases are now different, but exponents are the same. So rule 2 will apply, and therefore x must be equal to that base, which is 5. In my third example, I've got 2 to the power 3x equal to 64. 64, we need to change it to a base 2. 64 can be written as 2 to the power 6. So bases are now the same. Therefore, 3x on top must be equal to 6 on top, or exponent. But that is not in the simplest form. We want x alone. So we can basically just take the 3 over, divide it by the 6, which will give me 6 over 2 and equal to 6 over 3, and it will be equal to 2. In my next example, I've got the fraction x to the power 3 over 2. Again, we need to find a way to make bases the same or exponents the same. We can see 27 can be written as 3 to the power 3. But the exponents are not the same. We've got a 3 over 2 here and a 3. If we look at our exponential rules, we can now change that 2 over 3 by multiplying by its inverse, meaning the opposite or the inverse. 3 over 2 becomes 2 over 3. We multiply with that as an exponent. But the golden rule, remember, what we do on this side, we must do on that side. So on both sides, we multiply by 2 over 3. So that 2 over 3 and that 3 over 2 and 2 over 3 can cancel each other out. That 3 on the right side can cancel with the 3 on the other side over here. So those two 3's can cancel. We are left on the left side with an x because the exponents now cancelled, and we are left with a 3 to the power 2 on the right side, which actually gives me a value of 9. In my next example, I've got 8 to the power 2 minus 2 to the power x. In this case, we need to rewrite 8 so that we can have a 2. So 8 is 2 to the power 3, but we still have the 2 on the outside. Careful over here. That 8 is 2 to the power 3, but we do not remove this 2. We now have to just multiply according to exponential rules. The 3 with the 2 gives me a 6, and now we've got the bases the same, and hence we can say x must be equal to 6. In my next example, I've got 64, 5a, and 20 to the power 3. To rewrite 64 in terms of 2 to the power 6, and 20 we can write as 4 times 5. We're trying to make all the bases the same. That 4 can become a 2 now on that side. We've got 2 to the power 6 on the left side, 5a. The 4 we can write as 2 to the power 2. Right? First multiplying out the 3, of course, and then we can say we will now change it to 2 to the power 2. So that becomes 2 to the power 2, 3, and When we multiply 2 times 3, it becomes 2 to the power 6. So that 20 became 4 times 20. That 3 outside multiplies with the 4 and the 3, and we change the 4 into a 2 to the power 2 times 3 gives us 2 to the power 6. We can now have 5 to the power a on the left hand side, take everything else and move it to the right hand side, 2 to the power 6, which will be divided. So those two can now cancel each other out. 2 to the power 6 will cancel with 2 to the power 6. We are left with 5 to the power a is equal to 5 to the power 3. Bases are now the same, and therefore a is equal to the value of 3.